In nature, a tortoise is structured, a lotus leaf is structured, a butterfly is structured, and this isn't a whim of nature, but of evolution, in order to improve the functionality of their surfaces. That was our starting point. How can we structure surfaces in micro dimensions so that their properties improve?
Compared with their examples in nature, modern technology is still in its infancy, but man, with his inventive genius, is catching up fast. At the Steinbeis Research Center, Material Engineering Center, Saarland, research has been carried out on surface structures in nano and micro dimensions for years. Using interference laser technology, minute surface structures can be produced.
The DLIP technique, as we call it, works as follows. With one laser shot, we can directly structure the surface microscopically and periodically. The idea behind this effect is that the laser beam doesn't hit the surface directly. Rather, the beam is separated into several partial beams which are coherent with each other. In other words, they oscillate in the same phase and are joined again directly on the surface. Thus, interference patterns are created, which we imprint into the surface.
The partner in the project, TE Connectivity, is a world leader in connectivity solutions. A car today has roughly 2,500 connectors, with an upward trend due to electrification and autonomous driving.
With this new technology, we can reduce the insertion force by 30%. That means we can more or less put 30% more contacts into a connector housing at the same insertion force. Or we design high-pole plug connectors with fewer subcomponents.
The second step of the 5-year cooperation was to develop a pilot plant for the DLIP serial production. With this reel-to-reel installation in Speyer, it is now possible to structure a great number of connector contacts in a very short time. The transfer partners have applied for a patent for this new technique. The innovative idea is to structure the surface of the connector contact with a single laser shot, achieving structures of 1 to 2 micrometers. In order to reduce the insertion force, the team from Steinbeis and TE Connectivity experts developed an oil film, which becomes enclosed by the laser structure and is freed again at the first contact.
With this new process, we have captured the oil just like in a time capsule. It is ultimately only brought to the surface at the actual plug-in process. Otherwise, it remains simply hidden, has no contact whatsoever with the atmosphere, and can therefore not react chemically.
Überall dort, wo sich Teile bewegen, wo wir Reibung und Verschleiß haben, überall dort.
Wherever parts are moving, wherever there is friction and wear, structured surfaces can bring substantial progress. This is because friction is reduced and wear is drastically reduced, and thus the reliability of such machine systems can be mechanically ensured over a longer period of time. This also includes antimicrobial surfaces, where we make sure that multi-resistant germs cannot attach to surfaces or biofilms cannot form.
Sich nicht bilden können.
It is not new to copy from nature, but having technically advanced from visible detail even further into the nano range of natural surface structures is certainly worth a prize.